Assalamualaikum. Can you hear me? Guys, can you hear me?
Boleh, Doctor.
Yes, Doctor.
Can ya? So we continue our lecture on 3.4 modeling of RLC network. Okay, slide number 24. Okay, can you see my whiteboard? Hello, can you see?
Yes. Can, Doctor.
Okay. So we modeled the RCRL last week, and this week, since the university asked for hybrid or online teaching, so I moved to online teaching. Okay, by considering the RLC serial network with the input voltage VI, this one, and the voltage drop L is the output. Okay. Okay, so what I will do is I'm considering the drawing here. We have okay. So we want to model this RLC using the state space representations. Okay, approach. By considering the input as VI or supply and the output, which is at inductance. Okay, so choose the state variables as x1, t, which is here, q of t and I of t. Okay, so therefore, the derivative state variables are x1 dot t is dq over dt, x2 of t is di of t dt. Okay. So we mentioned over here, and then we use the Kirchhoff voltage law.
Men, namain!
Isapul pula. Okay, we choose the Kirchhoff voltage law, VI equal to VR plus VL plus VC, and replace all the corresponding voltage of VL, VR, and VC. So this one, there is integration. Integration symbol. Can you please correct your notes if some weird symbol or no symbol before I. So we convert the state variables. Okay, we know that I is equal to dq dt. Okay, which is the rate of change of electrical charge with respect to time. And then we insert this I, insert inside the main equation, the KVL equation. Then automatically we eliminate the integration symbol. Okay. So we get 1 over C Q of T, VI over VT. So we want to derive this equation, which is x dot equal to AX plus BU, which is known as the state equation. Okay. So state equation, which is x dot of T is equal to AXT plus BU of T. We already defined x1 as Q, x2 as I. Then we find the derivative state vector, x1 dot, x2 dot. So x1 dot is dq over dt, and dq over dt actually is I. And I is actually is x2. Okay. Okay, so this one you must understand how we get x1 dot equal to x2. Then x2 dot is equal to di over dt, and this one we have to derive. Okay, so the way we derive it, shown here. So this is your first state equation. Okay, equation number 1, first state equation. For the second state equation, we know that Q of T is integration of IT. And from this equation, okay, we replaced the QT inside the main equation. Okay, so we found di over dt minus Q of T over LC minus R over L IT and plus VI 1 over L multiplied by VI. So this one is x1, this one is x2, and this one is input. Okay, so therefore this one is actually is I dot and is known as the x2 dot. Okay, therefore you got the second state equation, which is x2 dot 1 over LC. Okay, x1 minus R over L, x2, and 1 over L U of T. So these two equations, the first one and the second one, okay, we will be used to build up the matrix later, but we have to find the output first, the output equation of the RLC, which is known as this equation, y of t is equal to cx plus du. Okay, so therefore we use the KVL equation. We replace V naught with VL because this is the output. Then we replace VL, which is equal to VR plus VC plus VI. Okay, So this one, VM. Okay. Then we get the equation VL of T. And finally, we get the VL of T inside the equations. Okay. Which is known here. Y of T. This one should be minus. Okay. Minus, minus. So if we look here, the symbol in the equation is losing. So we have minus R minus BC. Okay. Please take note. This one is minus as well. Minus, minus. Okay. This one is minus, minus. Okay. So therefore you get equation 1 and 2 rearrange. Rearrange in matrix form. Okay. So we have this one, which is known as a derivative state vector. Okay. This one is the state vector. Yeah, this one is input. Okay. Y of T is the output. This whole thing is matrix A, matrix B, matrix C, and matrix D, which is a system matrix, input matrix, output matrix, and feed-forward matrix. Okay, slide 29. Any problem? Any question? Ikhwan, any question? Tak datang. Tak datang, eh? Muaz, any question? Absent. Okay, Muhammad Uzair, any question?
Tak ada tu.
Okay, hadir. Muhammad Uzair hadir. So when I call your name, no response, I assume you are absent. Okay, next example is the modeling of RLC network, but we change the state variables. Previously, x1 equal to q, x2 equal to I. But now we change the state variable. Instead of q and I, we choose x1 equal to VR and x2 equal to BC. Okay, same circuit. We are using the same circuit. Okay, input same, and the output is same at the inductor. Input, output same. Okay, so we derive. Okay, our target is to find the state equation and the output equation, SE and OE. Right, for the voltage of the resistor is known as VR is equal to IR, and X2 VC, VC is 1 over C integration I dt. Okay, VL is equal to L di over dt. So now we derive the state equation using the Kirchhoff voltage law around the loop. Okay, so this is the equation. Vi is equal to VR plus VC plus VL is a one loop, single loop. Then we replace VL with L di dt. Okay. Then we bring L dt to the left, and Vi we move to the right. Okay. So what will happen is this one is minus VR, this one is minus VC. Okay. So this one is di dt minus 1 over L VR minus 1 over L VC. Okay. So derivative of the first state equation is x1 is equal to VR, x1 dot dVR dt. And VR, this one, VR is equal to IT, R, IR. So R is constant. We bring R to the front and leave behind di over dt. But di over dt is from here. Okay, so you replace di dt from our derivation just now in the slide 31. Okay, slide 31. Okay, insert inside, so you get R over L, Vi minus VR minus VC. And then simplify. Simplify, you will get x1 dot minus R over L VR minus R over L VC plus R over L VI. VR is x1, VC is x2, and VI is U, input. Therefore, we get the first state equation, which is x1 dot minus R over L x1 minus R over L x2 and plus R over L U. For the second state equation, okay, we know that x2 is equal to VC. So find x2 dot, the derivation, which is dVC over dt. Okay, but we know that I is equal to C dVC dt, current through resistance. Okay, so when we make dVC dt as the formula title, so I will become I divided by C. So that's why you get I over C in the equation. Okay, but I is not involved in the state variable, so we have to replace with V R over R, Ohm's law. Okay, so this I, VR over R, we replace inside here. Okay, so therefore you get 1 over RC VR, and x2 dot is 1 over RC x1. So no x2, no U of t, no input. Okay, so x1 is alone in the second state equation. So this is state equation number 2. So 1 and 2 rearrange so that it becomes in matrix form. Okay, so you will get derivative state vector, you will get state vector, you will get input. Okay, and this is matrix A, sorry, matrix A and matrix B. Okay, and the output is using the Kirchhoff voltage law. So since we declare that VL is equal to output, okay, so we create VL as the formula title, which is equal to minus VR and minus VC plus VI. So it will become minus x1 minus x2 plus U. So therefore, the second state equation is -1, which is matrix C, multiplied with the matrix DU, matrix FUA'AD. And finally, this one is the new state space representation, okay, where state variables are defined as VR as x1 and VC as x2. So it is different, different matrix A, B, C, and D. When you change the state variable, A, B, and C is different, but D maintain the same. If you change the state variable, previously x1 was Q, x2 was, what is x2 just now? Hold on. I, okay, x2 was I. Same circuit, but you change the state variables. Any question? Chong, Kang Yi, any question? Absent. Tan Jia Jian, any question?
Yes, doctor.
Are you present? Are you in the class?
Doctor, are you calling Tan Jiaxian?
No, I'm asking you.
Yes.
Who is this? Kuo Yi Hao, are you there?
Yes, doctor.
Okay, present. Magdi, are you there? Muhammad Magdi,
Yes, doctor.
any question?
No.
Question. Azim Zaharuddin, are you there?
Yes, doctor.
Any question?
No, jelas.
Jelas, eh? So, if you don't have any question, I have a question for you. Hello? Hello?
Ya, doctor. Selamat, doctor.
Tadi nama siapa?
Azim, Doctor panggil saya, doctor.
Azim. Azim,
Ya, doctor.
RLC circuit,
Okay.
RLC circuit single loop. What
Okay.
is the effect if we change the two state variables? In case 1, x1 equal to q, x2 equal to I. In case 2, x1 equal to VR, x2 equal to VC. What is the changes that happen?
Macam mana, doctor? Sekejap, saya cuba tulis.
Apa yang berlaku bila
Okay.
kita ubah state variable from x1 equal to q, x2 equal to I, to another new state variables, x1 equal to VR and x2 equal to VC. What happened? What changes happen?
Kalau dekat matrix, dia akan berubah.
In English.
If we are at matrix solution, will different lah. Change
Matrix,
the A, B, and C, D.
matrix A, B, and C will change, but
Yes.
D maintain
Ah,
as usual. Okay,
okay, doctor.
that is the effect. Okay, learn, eh? Ainul,
Yes, sir.
are you
Yes,
there?
sir. Yes.
Any question?
No.
Farisha, are you there?
Yes.
Adil?
Adi.
Adil, okay. So slide 37. What is the number of example? Slide 37, Farisha.
What is it?
What is the example number? Slide 37.
3.5.
Okay, example 3.5, two loop system. Everybody look, slide 37. I will call your name for the kehadiran, for the attendance. All right. So we have two loops, which is I1 and I2. And this is loop 1. And this is loop 2. Okay. So find the state space representation if the output is the current. The output is the current through resistor, IR. So there is a node here, which is this node. This one is IL, this one is IC, and this one is IR. Yeah. Izzah.
Yeah,
Izzah,
yeah.
are you there?
Yes.
Right. UTM or Kampong?
UTM.
Okay. What is the Kirchhoff current law at the node? Node 1. What is the Kirchhoff current law at node 1? Ni, node 1.
I L equal to IR plus IC.
Again? Repeat again.
IL equal to IR plus IC.
All right. Okay. Thank you very much. And then the state variables is defined by x1 equal to VC, x2 equal to IL. Okay. Output IR, which is Y of T. Input is equal to U of T. Okay. Homer Sultan. Homer Sultan.
Yes, doctor.
Kaki?
Yes, doctor.
Okay, louder. If the state variable is x1 equal to VC, x2 is equal to IL, what is the derivative state vector for this case? Homer,
Yes, doctor.
can you answer the question?
I'm not sure.
Not sure. Astaghfirullahalazim. Nadia? Same question goes to Nadia. Nadia, are you there? Tak hadir.
Yes, doctor.
Ingat tak hadir. Ada tak? Same question goes to you. What is the derivative state vector if the state variable is x1 equal to VC, x2 equal to IL? Nadia sleeping. Farhani. Farhani. Tak hadir. Tian Hian Yong.
Yes, doctor.
Same question.
Doctor, can you repeat the question because just now my internet is lagging.
Okay. If the state variables is x1 equal to VC, x2 is equal to IL, what is the derivative state variables? Don't know. Apa chưa tahu? Okay. Tak tahu Nadia, you know the answer? Nadia tak datang Okay. Nadia tak ada.
Yes, Doctor.
Kau ni orang panggil dengar ke tak dengar? Apa jawapannya? What is the state variables? Derivative state variable. The derivative state variable is dvc dt, and the other one is dil dt. See, in this question, the state variable x1 is equal to vc, x2 is equal to il. So my question is, what is the derivative state variable? So you have to differentiate lah. X1 become x1 dot. So it is dvc dt, and x2 become x2 dot, which is dil dt. Faham tak, Nadia?
Faham, Doctor.
Lambat sangat. So now we label already the IL, IR, and IC, and note over here. Okay, then select the state variable by writing the derivative equation for all energy storage element, which is inductor and capacitor. Why we call inductor and capacitor energy storage element? Hafiz. Tak datang. Hafiz tak datang. Amir. Muhammad Amir.
Okay, the capacitor stores the electrical charge and inductor stores the the magnetic charge.
I don't understand your answer. Can you simplify? Why we call inductor and capacitor energy storage element?
Because the capacitor stores the electrical charge and the inductor stores the magnetic charge.
Not very clear. Fast Lisa. Fast Lisa. Lisa. Lisa tak datang. Lisa tak datang. Hah? Lisa tak datang.
Because dia charging and discharging.
Because charging and discharging. Because inductor and capacitor have the capability to store the electrical energy. That is the answer. Okay. So VC is equal to 1 over C IC dt. IC, current through capacitor, is C dVC dt. And voltage at inductor is L dIL dt. These three formula is come from the, what do you call that? The table that I show in chapter 2A and chapter 3. Okay. Go on. So now we apply the Kirchhoff voltage law and current law to obtain IC and VL in terms of step variable VC and IL. Okay. So you have to find the state equation. Okay. So in this case, you have to find the x1 dot and x2 dot in terms of VC and IL. Okay. As shown here. Right. So this is the KCL, Kirchhoff current law. Okay. So IC will become IL minus IR, but IR is equal to VC divided by VR. Okay. Why VC? Why VC? Why not VR? Isam. Isam. Calling 1, calling 2, calling 3. Isam tak hadir. Nur Syuhada.
Yes, doctor.
Why VC over here in equation 3? Why not VR?
Because the state variable is VC.
Ha? Kamu kat mana, bah?
It being stated in
Because BR is equal to BC. Kan? But VR is not state variables. VC is state variable. Okay? Understand?
understood.
Kau kat mana, bah? Kau take it down belum?
UTM, doctor.
Okay. 1 over R VC. Okay? VC, and it's supposed to be VR. But VR is not state variable. Therefore, we change. Instead of VR, we use VC. Plus IL. IL is the state variable. Okay? This one is state variable. This one is state variable. So next is we use the around the outer loop. Around the outer loop, the theory said that we only consider the outer loop, like my drawing just now. Okay? And we ignore R. Ignore R. Okay? In the outer loop. So R, ignore. Ignore R. So VI is equal to VL plus VC. Okay? R, ignore. That is the outer loop. Don't ask me why. It's the circuit theory. Okay? Then VL is equal to minus VC plus VI, equation number 4. So now we substitute all the result of equation 3 and 4 inside equation 1 and inside equation 2. Okay, so C dVC dt equal to minus 1 over R VC plus IL, equation number 7. Okay, and this one we have to move to the right. Okay, and L dIL dt equal to minus VC plus VI, equation number 8. And L we have to move to the right. Rearrange, susun semula, rearrange. So dVC dt is equal to minus 1 over RC VC. So this is the x1 dot. This is state variable x1. This is state variable x2. And this is VI is equal to U. DIL dt is the second derivative state variable. VC is the second state variable. Sorry, first state variable. IL is the second state variable. And VI is equal to input. So now we already have the matrix. Okay. Plus U. So this one will be 1 over RC, 1 over C, 1 over L. This one is 0. And this one is 0, 1 over N. But the output of the equation is equal to BC equal to BR, which is equal to Y of T. Okay? So IR is equal to BC divided by R. Because This is due to VC equal to VR. So Y of t is equal to 1 over R x1. Okay. So therefore, you get equation number 12. This is the state space representation. Okay, for the whole system, as shown in the slide number 12 and 13. Akil. Akil. Calling
Yes,
one. Calling two. Akil.
Doctor.
Any question?
No, Doctor.
No, Doctor. Yang Shutong.
Yes, Doctor.
Any question?
I have no idea. Sorry.
No idea.
Yeah.
Ihan. Any question?
No, doctor.
Can't hear you. Ihan.
No.
No, no,
No
no.
question.
Tan Jia Jian. Any question?
Yes, Doctor.
Any question?
No.
Tai Beng. Any question?
No, doctor.
Miss Uy. Miss Uy. Any question?
No question, doctor.
I
No
have
question,
question
doctor.
for you. I have question for you.
Okay,
Miss Uy,
doctor.
what is the size of metric C in this case? Size of matrix C in this question.
2 times 1.
2 times 1. Matrix B.
1 times 2.
1 times 2. Matrix A.
Matrix A, 2 times 2.
2 times 2. And where is matrix D in this case?
Sorry, doctor. What is your question?
What is matrix D in this case?
Matrix D, it doesn't have matrix D in this situation.
Matrix D is not
So,
exist. Is not exist.
yeah, it's not like this.
Okay, very good. Okay. So far, so good. So what is the time now? 10:43. Okay. We have a break for 10 minutes. Okay, guys. Hello, guys. 10 minutes break.
Okay.
Okay, Doctor.
Kalau break laju aja. Okay. Okay, sekejap ya. Rehat sekejap. We'll be back in 10 minutes time. Okay, thank you. Okay, we continue. Second half, slide number 42. Sharon, slide 42. Sharon. Alright. Nabil, slide 42.
Yes, saya, Doctor.
What is the example number? Slide 42.
Slide 42. Example 3.6.
Okay, example 3.6. Tolong bacakan.
Given the RLC system describe a set of state variable x1t and x2t shown below, where x1t is capacitor voltage equal to VCT and x2t equal to inductor current, which is ILT.
Okay.
Determine the state space representation if the input is UT and the output is VCT.
The choice of state variable is intuitively satisfactory because the stored energy of the network E can be described in terms of this variable.
Lisa. Lisa. Cik Lisa. Datang. Gabriel.
Yes, doctor.
Can't hear you. Louder. Can't hear
Yes,
you.
doctor. Can you hear me?
Yeah, okay. What is intuitively? What is intuitively? Intuitively.
Meaning it's like according to how it usually function, how it usually works in other, like based on the other systems.
Is it from Google Translate?
It's just based on my own understanding.
Okay. Nadia, what is intuitively? Nadia tak datang. Intuitively. Huh?
I'm here.
What is intuitively?
Direct reception.
Direct
Reception.
receptions. Not according to the function lah, intuitively. So you can see from this problem, we have two loops. Okay. One is the L1, one is L2. And we have one node over here. Okay. So what is the current over here? Is U of T main current, U of T, then this one is IL, and this one is IC. Okay. So now the state variables is X1, BC, X2, IL. Okay, so that is the state variable. So what is the derivative state variable? Chua. What is
Yes.
the derivative state variable? Tak datang.
Ada.
Ada ke tak ada?
Ada.
Kuat sikit suara, tak dengar.
Okay.
Tahu. Tak tahu. Miss Chan. Miss Chan,
Yes, doctor.
if X1, the state variables, first one is VC, X2 is IL, what is the derivative state vector? State variables.
dVc over dt and dIL over dt.
dVc over dt, X2 dot, dIL over dt. Okay. So at the first junction here, we can see that the current source is U of T. So usually we use VI, but now we change to current source. Okay. So it also can be the input of the system. Okay. So that is the input. Input is U. Output is VC. Okay. Which is equal to X1. Okay. So U is equal to IC plus IL. Current source. But now we want to find IC. Okay, we want to find IC because our target is we want to find DI over DT. So IC is equal to C dV C dt, okay, equal to U minus IL. Okay, so on the right hand loop, which is loop number 2, we provide the equation describing the rate of change of the inductance. So this is loop number 2. What is the KVL over there in loop number 2? In Young, what is the KVL in loop number 2?
VC is equal to
Mhm.
LDI over DT plus
VC is equal to VL plus VL.
VR.
Okay. Okay. In Young, third,
Yeah,
VL plus VR, eh?
yeah.
Okay, so VL will become the formula title, and then is equal to minus ILR plus VC. Okay, so this current flowing through L is equal to the current flowing through R. Okay, plus VC. So now the output equation is V naught is equal to ILR. Yeah, RIL. R is constant, IL is the state variables. This one is state variable X2. So we have the two first order differential equation and output signal in terms of the state variable X1 and X2. Okay, so X1 is VC, X2 is IL. Okay, and X1 dot, as Miss Chan said just now, and X2 dot is equal to DIL over. Okay, so we will get this equation, state equation number 1, state equation number 2, and the output equation. Okay, so this is your X1 dot. This is your X2 dot. Okay, so you have X2, you have U. X1 tak ada. No X1, not exist. And this one is X1 and X2. So no input, no U in equation number 2. Okay, and this one no X1, no U for the output equations. So we arrange. Okay, I'm sorry why, I don't know why when I do the conversion, the matrix is like this. Arisha, you have any comment why when I convert this square bracket become not aligned? Arisha?
Yes, sir.
Why when I convert from PowerPoint to PDF, the square bracket is not aligned?
Not sure. Maybe I
Investigate.
don't know.
Investigate.
Yes. Okay.
Okay, X1 dot, X2 dot. So we have the state space representation for this particular circuit. Okay. So far, okay. Okay, if R is equal to 1 ohm, C is equal to 1 farad, L is equal to 1 Henry, yeah. Find the numerical values of matrix A. If R equal to C equal to L equal to unity, what is the value of matrix A? Abdul Munim. Abdul Munim. Absent. Ilmu name absent. Farhani. Datang. Farhani absent. Polling 1, polling 2. Farhani. Datang.
Yes, Doctor.
Farhani.
Yes.
What is the value of A? Matrix A. Minus 1. 1 minus 1. B for honey. 1, 0. Matrix C. 0, 1. Okay, when we substitute R, C, and L equal to 1. Find the transfer function model. Transfer function model meaning TM. Okay, so we already replaced the value. So we have to use the formula in order to convert from state space to transfer function. Use formula. Formula is C Si minus A minus power of -1 multiplied B plus D. So what is the -1 stands for? Chris, what is -1 in this formula stands for? Ratang. Amir, what is -1 stands for?
That
Website. Huh? -1 stands for
inverse matrix.
inverse matrix. Okay. So I in this formula, I identity matrix. Repeat after me. Identity matrix.
Identity matrix. Identity matrix.
S. What is S? What is S? Lutung. What is S? Laplace operator. Okay. So you insert the value of C inside this formula. Si minus A inverse -1. Insert the value of matrix B and matrix D. D, of course, not exist, so we assume as 0. So you multiply, you find this one first, Si minus A. Si multiplied by 1, 0, 0, 1. This is a matrix identity. Okay. 1, 0, 0, 1 for 2 by 2. Minus matrix A. This is matrix A. Okay. So you get this one. Okay. Which is S1 minus 1. S1 minus 1. S plus 1. Okay. Okay, guys. Rwanda, do you understand? Hello. So what is the formula for inverse SI minus A? Miss Uy,
Yes, doctor.
inverse formula, inverse matrix formula.
Matrix divided by determinant of the matrix.
Huh?
Oh,
This one, the one that I wrote here.
oh, give the formula, is it?
What is the definition of inverse SI minus A?
The matrix itself divided by its own determinant.
Huh? Adjoin PG. Correct. This is what you mean?
Yes, doctor.
What is adjoin? What is adjoin? Miss Uy.
Changing the position of A and D, and then the value of B and C will become negative.
Okay, I think the one that you try to mention here is this S plus 1 and S change the seat, right?
Yes. Yes.
Change the seat. Then the perpendicular, you negative both numbers, so it will become positive 1 and minus 1. This is what you mean? This is what
Yes,
you mean?
yes, doctor.
And then the final one is the determinant. Miss Chan, how you find the determinant of this? Miss Chan,
Yes, doctor.
determinant.
Determinant. The top, the row one first, cross multiply, then minus
Okay,
another one.
this is what you mean?
Yeah.
Huh? Tak dengar.
Yes.
Yes, okay. Sure. Okay, so that's why you get this one. Okay, I already shown in the whiteboard. Okay, then this value inside the formula, you multiply. Okay, so now is to multiply. Okay, so to multiply, okay, C is, what is the C value? 0, 1. This one is 1, 0, 10. Okay. Syuhada, what is inverse SI minus E? The value. Syuhada. Datang. Syuhada tak datang. No. Okay. So how are we going to multiply this? Arisha, how are we going to multiply this?
Sorry, doctor.
How to multiply this? We define the, what do you call that? The size first. Yeah.
Yes.
This is 1 multiplied by 2, size, betul. 2 by 2. This one is 2 by 1.
2 by 1.
Okay. So if you want to multiply the matrix, you have to see the initial one and the end must be the same. And so in this case, you multiply this one first. Okay. This one. Or if you don't want, you want to multiply this one first also can, because it's end with 2, start with 2. Okay. So I do the left one first. 0 multiplied by s plus 1. Okay. 0. Plus 1 plus 1. Okay. 0 multiplied by minus 1, 0. 1 multiplied by s, s. So this is left. Okay. So this is 1 by 2, 2 by 1. So 1 multiplied by 1 plus s multiplied by 0. This one, eh?
One.
Okay. But this one, you have the denominator. The denominator is s squared plus s plus 1. Okay. Okay, so therefore you get this one. Okay, the derivations. Allah Rabbi. Anik. Anik. Anik Tanchan Gia. Tak datang. Azim. Azim.
Ya dah.
Hadir ke?
Dah dah.
Hadir. Awak kat mana?
Saya dekat IDM.
Right. This is what is the system order for this? GS. System order ni berapa?
2.
System order 2 sebab the highest order of denominator is 2. Then kita masukkan dia ke dalam GS ni. Unity feedback. Okay. Then we inject step signal. Where do we get the step signal? Azim, where do we get the step signal?
From the order.
From the function generator lah, square wave kan?
Yeah.
So you will get the output CS as shown here. Okay. I cannot show here because my MATLAB have a license problem from EDM. Later I will show you. Okay. This one I will show later in the face-to-face class. Okay. Because my MATLAB is not working.
Doctor,
Yo.
the assignment will be with the MATLAB?
Yes, Simon will use MATLAB.
Okay.
You have MATLAB? Akhi, you have MATLAB?
MATLAB? I think I have the license.
You have the license?
Yes, but I didn't open that for a long time.
Your license is from where?
I get from UTM, I think.
UTM?
Yes, I put my account.
Okay, because I cannot log in now. I don't know why. Is it you can log in now? Is it available?
I didn't try for a long time. Maybe it's expired already.
So maybe expired. I tried to renew, but I cannot.
I will try to.
Okay, shukran, Habibi. Right. Now we in the slide number 50. Muhid Asam. Muhin Asam.
Yes, doctor.
Can't hear you.
Doctor, can you hear me?
Slide number 50. What is the number of example in slide number 50?
3.7.
3.7. So 3.7 is 2 loops. Okay, guys, we have 2 loops. How many active elements? Ashwin? How many active elements in this circuit?
Doctor, there are three active elements.
Huh?
There are three active elements.
Ashik? What
Yes,
is
Doctor.
Ashwin, what is the numbers of active element in the circuit? Example 3.7.
There are three active elements, Doctor.
Can you name it?
The two capacitors and one inductor.
C1, C2, and L.
C2.
How many passive element in the circuit?
The resistor, Doctor. One resistor.
What is it? The system is single output, single input, single output, or multi-input, multi-output?
It's a single input, single output.
Single input, single output, as mentioned here. Guys, input Vi, output V0. What is the state variables? How many state variables in this circuit?
3.
Can you name it? Fadina. In English. How many state variables in the circuit?
3.
Name it.
VC1T, ILT, VC2T.
Oh, kat gua ke? Oh, dalam gua ke? Syuhada,
Yes, doctor.
can you name the derivative state variable, please?
Derivative x 1 dot equals to dvc over dt x2 dot equals to dil over dt x3 dot equals to dvc2 over dt.
Bagus, bah. Bagus. So now we have a third order system because we have three state variables. Three state variables, so expected model will be third order system. Matrix E will be 3 by 3 size. Okay. So now we do the solution. So the output is V0. The V0 is V0 kat mana? Lisa, V0 kat mana? Output. Lisa. Tidur ke ni? V0 kat mana?
C2.
Hah? CT?
C2.
C2. Kejut aku. Okay, VC2, right? So now we write the okay. We write the derivative relation for energy storage element for C1, C2, and L, as shown here. IC1, C dVC1 dt, VL, L dIL dt, and IC2, dVC2 dt. Okay. So use the Kirchhoff current law. Okay. At this node. Okay. So you can see that at that node, we have IC1, IR, dan IL. But IR is equal to IC2, okay? Because it's in the same loop, R and C2. So write the Kirchhoff current law here, okay? And IC1 is equal to IL, IC2, okay? As mentioned here. Okay. So we replace IR with X2. Then IC, okay, is equal to IL plus 1 over R VL. Okay. So where VR is equal to VL and VC. Ini apa benda ni? Macam ada silap ni. Tak apa, nanti kita betulkan notes. So VI VC1 plus VL, VL VC1 plus VI, and derive the current IC2 and replace all and simplify. You will get the X1 dot, X2 dot, X3 dot plus Y. Okay. Then rearrange, so you will get the 3 by 3 matrix system. 1 by 3 input matrix and 3 by 1 output matrix. This one, I think we have a technical problem writing main conversion. I have to refer to the main slide why something is wrong somewhere there. Okay, but the answer is correct. Okay. So we move to the next example, slide 61. So now we have 3 loops, L1, L2, and L3. Okay, single input, single output. This is the input, and V0 is the output. So you have to find the X1 dot, dV1 dt, X2 dot, dI4 dt, and X3 dot, which is dV dot, dV0 over dt. Okay, which is the capacitor, voltage drop at the capacitor. As usual, you add all the branch current and node voltage to the network, label it, and write the differential equation to describe the energy storage element. dV1 dt I2, dI4 dt V2, and dV0 dt is equal to I. So the calculation become easy due to the fact that all component C1, C2, and L is equal to 1. Okay. So the state vector with 3 state variables, okay, X1, X2, and X3. And derivative state vector is X1 dot, V1 dot, X2 dot, I4 dot, dan X3 dot, dV0 dV0 dot. So obtain I2, V2, and I5 in terms of the state variables, okay. Then simplify, so you get V2. Substituting V2 in I2, okay. Then you get I5. Then therefore rearrange the equations. So you will get the final state space representations, okay. Is a 3 by 3 is a third order, okay. Third order system. Next example is slide 67, but now we have only 2 active elements. So 2 active elements, meaning that we have 2 state variables, okay. So output is IR, input is VI, X1, I2, X2, VC is the state variables. So therefore, the derivative state variables will be X1 dot, dI2 dt, X2 dot is dVC dt. Okay, so as usual, add the branch current and node voltage and write the differential equation related to the energy storage element. V1 dI2 dt, I3 is a C dVC dt. So this one actually Okay, this one is a L there and C there. But since L equal to 1 and C equal to 1, that's why it left there as V1 di2 dt and I3 dVc dt. And the state vector is here. And automatically, you know that the derivative state vector will be di2 dt and dVc dt. Okay. So do the substitutions, okay, until you get the I2 and VC, di2 and dVc, okay. And the output is IR. In terms of the state variables, it will be I3 plus 4V1. And this one is the current source, if I'm not mistaken, yeah. Is the current source. Okay. Replace with the state variables items and then simplified, you will get the state space representations. Right, so we continue to the next example, slide 71. Okay, so now we have 3 loops. Same approach, okay, all is equal to 1, but 3 state variables, okay. So we use the, write the differential equation for each energy storage element and observe the 3 current. Now we have 3 current, I1, I2, and I3. Do the same procedure, write the node equation, Kirchhoff voltage law, Kirchhoff current law, simplify it, then you will get the 3x3 state space representations. So for this week, we ended here. Okay. And we will continue back again in Wednesday. Any questions? Any questions? Ada soalan?
Doctor.
Yes, Abdul Munim.
Yes, when will be the test one?
Sorry?
Test one.
Test one is on 11.
11. With which topic, 1 and 2?
Most probably chapter 2A and 2B until translational mechanical system.
Okay, thank you.
Rotational not included.
Okay.
I will remind you from time to time once I got the information from the coordinator. Okay.
Okay, thank you.
Pavitran?
Yes, doctor. Yes, doctor.
Where are you?
In uni, doctor.
In UTM?
Yes, doctor.
Thought you in the hometown.
No, doctor. Tomorrow only, bye, doctor.
Happy Diwali.
Thank you, doctor.
Ashik? Ashik,
Yes, doctor.
where are you?
I'm still in Taman Pulai Utama, sir.
Oh, I thought you were in India.
No, sir, I wasn't able to go.
You celebrate Deepavali?
Yes, doctor, but I'll celebrate it here.
Happy Diwali.
Thank you very much, doctor.
Nandri. Any question? Chong? Chong Kan Yi? Any question?
No question, doctor.
Miss Uy, any question?
No, no question, doctor.
Miss Chan, any question?
No question, doctor.
Who Farisha, any question?
So far, no.
So far, no. Farhani, any question? Tak datang. Okay, I think sampai di sini saja. I will share the YouTube recording. Okay, once I upload to the system. Thank you very much and see you on Wednesday. Bye.
Thank you, doctor.
Thank you, doctor.
Doctor.
Bye, doctor.
Thank you, doctor.
Thank you, doctor.
Thank you, Doctor.
Thank you, Doctor.
Hi, Doctor.
Mm.
Not got the Q, then is also got attendance or what?
When I call your name, you respond, meaning that you are present in the class. If you don't respond, meaning that you are absent in the class.
But if the name is not Q, is how about?
The name is not?
Not Q. The doctor not mention my name just now. Yeah.
Did I mention your name? Do you respond?
No.
Why?
Because I just now got the another class. Yeah.
Huh? You have
Another.
the...
Because the doctor have a delay time, so also online class. So I had to crash the time. Yeah.
What class? Clash with...
English class.
Okay, what time the English class finish?
8 a.m. until 10 a.m. But it's online, so the doctor had a delay some 15 minutes.
Oh, early in the session. Early in the session, I
Yeah.
call your name. Yeah, okay,
Yeah.
okay. Okay, understood. Okay, you the respond. You are present. We'll cancel the absent. Okay?
Okay.
Okay.
Thank you, doctor.
Session.
Hello, Doctor.
Yeah.
Just now you didn't mention my name, so I consider absent or present.
Assume present. With so many students, we have 66 students. I cannot call one by one. Shoot by random.
Okay, thank you, Doctor.
Mr. Teo is in the class.
Okay, thank you, Doctor.
Sure. Umaima, Habchi. Umaima, Habchi. Umaima? Absent.